Well, hi everyone, and welcome to this week's topic, which is sea level rise. Sea level rise is probably the most spoken of topic when it comes to climate change, obviously, besides temperature. Of course, the reason being ice melts. Once you melt ice, that's on land, that ice finds its way into the ocean. Sea level rise is somewhat insidious, meaning it's slow acting. It isn't something that happens very fast, but it happens. And so it's sort of one of those really significant aspects of climate change that most people have to deal with because most of civilization in the big cities on Earth lie on coasts. Think about it. Think about all the big cities: London, New York, Tokyo, Rio de Janeiro, Miami, Houston, Los Angeles, Seattle, San Francisco. Um, think about cities like in Barcelona, Rome, Italy, anything in the Mediterranean Sea, out in the Pacific, Hong Kong, Sydney. Get it? So it's a big deal because of the fact that most of civilization has come to sort of rely on cities for the majority of commerce and trade. And of course, a lot of people live near the ocean. So this image right here kind of gives you a sense of, all that ice in Antarctica and Greenland, but specifically Greenland from this perspective. And it all basically melts on top of the ice and it empties into the ocean. And you may not think this adds much, but over a long period of time, it does. So that's what we're going to talk about today. If you doubt the impact of humans on the environment, here it is. There's a surfer. Look at all the garbage on that wave. And this is obviously pollution, but everything is also tied to other things like climate change, for example, affects ecosystems, affects cities, affects health, affects agriculture. So there's so many ramifications to this sort of human aided, human caused problem that we're talking about in this class. I just happen to like this image because it shows you how everything is really not that far from everything else in terms of impact. Okay. So the reality of sea level, it is rising. That's not doubted by anyone. It is very well measured. Okay. So we'll talk about the idea of two main causes. Of course, melting ice is sort of the big one. Melting ice over land, not ice that's already on the ocean floating. And of course, thermal expansion, meaning when water heats up, it expands. Anything heats up, it usually expands. So that expansion makes the ocean cover more area. And when it covers more area, that means it's pushing in land. Thermal expansion of deep ocean waters. So we talked about the idea of, if even if greenhouse gases were stopped, and even some of the excess of carbon was removed from the atmosphere, sea level would still persist for many centuries. It would slow down, but it would still continue. Coastal communities basically have to plan for this. And places like Miami, Florida is already dealing with that. And you'll get to see this in a video later in the semester. And so the rate of sea level rise from 1962 to 1990 was 1.5 millimeters per year. That may not seem like a lot to you. And the rate from 1992 to 2012, 3.2 millimeters per year. So it basically doubled. Now you may think to yourself, in fact, it more than doubled. You may think, well, what's the big deal? That translates to about 1.13 inches a year. But if you add that up over 2 years, over 10 years, over 20 years, now you're talking about several inches up to a foot. And if you live in a very flat area like South Florida or Bangladesh or parts of Asia, that's where a lot of people live. Or if you live in really small islands in the Pacific Ocean that are very close to sea level, any change in that sea level has a very significant impact on daily life. Now, if you live in the middle of Kansas, sea level rise doesn't mean that much, if anything, to you. But there are many, 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 really billions of people that are at risk throughout the world. Satellites are really good at measuring this. They can do this measuring of sea level rise to a very, very, very fine point. And here's the idea from, again, 1991, 1993. Notice how the change is sort of scattered, but it is very persistent. And the slope here is 3.18 millimeters per year, meaning the change in this per year. The change as you go in further in time from one year to the other, how much do you rise? So on average, this slope, this is very basic algebra right here, y equals mx plus b, if you'll recall from algebra, it is 3.18 millimeters per year. So if you take that into the next 10 years, that would be 10 times 3, so that would be 30 millimeters more. And that is a significant increase in sea level in a very, very short period of time. Okay, of course, another one here shows you a 3.29 millimeter per year change. That's, again, pretty close to what was found before. Here are some of the basic differences. There are regional differences. Some of them are caused by wind, and some of them are caused by how hot the ocean is. Okay. In the Western Pacific Ocean, rates are higher because the Western Pacific has winds blowing roughly in the same direction all the time, and it is the hottest water on Earth. So the rate there is about 10 millimeters per year. So that's almost half an inch. In this image right here, this is Africa, this is Australia, this is South America, the US. Wherever you see the red, that would be the Western Pacific. So that would be this. Shows you that we're talking about this rough color. And this is basically the idea of about 10 millimeters per year. In other areas, is actually a sea level drop a bit. So notice how it's not perfect and it's not uniform throughout the Earth. There are areas where it's more significant and in other areas where it's less significant. However, it is a global problem, and over time, everybody will experience some amount of increase. Here's the idea. Remember those RCPs we talked about? RCP 2.6, 4.5, 6.0, and 8.5. Remember those scenarios? Well, of course, this is the better scenario, 2.6, and this is the worst scenario, 8.5. But this is talking about in meters. So basically anything in the dark red implies anywhere from about 3/4 of a meter to over 0.8 meters. So that is basically 2 feet of sea level rise at the worst case scenario. That is significant. And that is significant because that would mean the displacement of hundreds of millions of people who would no longer be able to live where they live right now. Again, some of the Western Pacific sea level rise. And there's this thing, you know, the idea of the Pacific decadal oscillation, El Nino, La Nina, remember that? So La Nina is the negative or cold phase, and then El Nino is the positive or warm phase. So during El Nino events, the Pacific, the sea level rise in the Pacific is less, and in the La Nina, remember La Nina is stronger than normal. That means the winds that are blowing to the west are blowing even stronger during La Nina events. Okay, and again, remember the trade winds during La Nina, the trade winds are strengthened. Therefore, they tend to push the water in one direction more significantly. And of course, during El Nino, the trade winds either weaken or they reverse. And here's the idea of PDOs in the positive or El Ninos, PDOs in the negative or La Ninas. Okay, and during the blue or La Ninas, the sea level rise tends to be less significant, and during El Ninos, they tend to be exaggerated to some extent. Let's look at some of the sea level rise basics. Are winds changing as a result of global warming? Well, that's definitely a possibility because you're changing the basic weather patterns that eventually turn into climate patterns. So if there's a 5 to 10% increase in wind speed over the oceans, that means you experience stronger sea level rise because the winds are pushing that water towards a coastline much more strongly. Okay, and here's the idea. So this is North America. This would be Australia here. And here in the Pacific Ocean, you tend to have a significant increase in the wind speed. And that significant wind speed increase, which may be tied to hurricane activity, tends to push water in one direction much more significantly, aiding in the sea level rise sort of scenarios. Okay. And of course, the idea of waves, so wave heights or waves tend to be stronger. The stronger the wind. Here, the pattern isn't as clear as with the previous one. There is a significant increase where you see the yellow and the orange, but there is a significant area where it's either neutral or very less significant in terms of wave heights. Okay, the effect on global mean sea level rise is not that well known simply because the idea of linking El Nino, global warming, and how they interact is not particularly well understood yet. I know this is not a very palatable and satisfying answer, but unfortunately, that is just simply not a particularly well-known connection. The bottom line is, and what I really want you to get out of this is, as you begin to melt ice that's on land, that ice turns to water and then it goes into the ocean. So there's a long history of sea level rise on Earth. So let's turn away from the presentation and go into Google Earth briefly. So when you look at, for example, here in Google Earth, this lighter blue is what's called the continental shelf, meaning it's a very, very shallow ocean. If you go here, the ocean here is no more than 20 to 30 feet deep, maybe a little bit deeper in spots. You have to get into sort of the darker blue before you get into really deep ocean, okay? So when you go over to, say, the United States, for example, and you begin to look at Florida, notice how Florida is a very flat area, right? If you've been to Florida, you know how flat Florida is. There are no mountains. There's no mountain ranges in Florida. Florida is a very flat place. And Florida is full of holes, full of sinkholes. Florida is one big giant chunk of limestone. In the distant past, when the world was warmer, Florida was completely underwater. So you can go to parts of Florida, Kissimmee, Orlando. You can go really anywhere here and begin to dig. And when you dig, what you find is seashells. Now, when sea level is lower, because we're in the middle of an ice age, Florida nearly doubles in size because the ocean either to the east or to the west of Florida is very, very shallow. So it doesn't really take much for Florida to become a little bit bigger. Now, as you look in the United States, so when you look at, for example, the coast of North Carolina, let's looking a little bit closer here. The cities of Fayetteville, the city of Columbia, South Carolina, or the capital, Augusta, Macon, this whole area here, this is what's called the Piedmont. And notice how there's a very distinctive line. I don't know if you can kind of see it right through here. And this is as far as you can navigate in a river, which is why you find the city of Augusta, the city of Columbia, why you find the city of Fayetteville, the city of Rocky Mount, all these places right here. This is as far as you can go in. In the distant past, this used to be all covered by ocean when the world was much warmer. So when you dig in this whole region here, you find seashells. You find seashells a good 100 miles from the shore in North Carolina, in South Carolina. So that tells you it's a very, very different place. In a much warmer climate, New York is a much bigger state. New York City is a much inland city. So the river would continue through this whole region. Jersey would be further out. Long Island wouldn't be an island, it would simply be land. So it would extend from here further south through what we call Long Island. The Long Island Sound would be basically not water, it would be land. It would be essentially connected to Connecticut. The same thing happens in the opposite when it's a sea. That's when it's an ice age. When it's, of course, a much warmer world and the sea level rises, then most of New Jersey is now underwater. Long Island doesn't really exist. New York City is underwater as well, as would be coastal Connecticut, Rhode Island, New Jersey, Delaware, Maryland, and this whole sort of region. So you begin to see from the perspective of humanity, if you look at a place like, for example, India or Bangladesh. Here's India on the other side of the world, 1.4 billion people. Here is the state of Bangladesh, which is super populated and dense, very, very shallow. It would not take much for all this land to be underwater, displacing literally hundreds of millions of people. And where would they go? To Myanmar or to India on the other side? These are populations that are not particularly friendly towards one another. So this is kind of a big deal. It's getting away from climate change and getting into the effect of climate change on people, cities, governments, states. If you think about the idea of how governments react to one another, well, if they're friendly, then it's probably a good thing. But if they're not friendly, then they sort of had to deal with one another. And sea level rise is one of those problems that is going to force many people to have to deal with their neighbor. And by people, I mean countries, states. And you can look at places like the Philippines and Indonesia and Malaysia. You can look at, of course, China, one of the most up and coming economies in the world, Korea, Japan, and of course, not to be outdone, the US. We have our own problems to deal with. All of our big ports, Seattle, Long Beach, Houston, New Orleans, Tampa, Miami, Charleston, South Carolina, the port of New York, New Jersey, Boston, all coastal cities, all definitely affected by climate change and sea level rise. In the US, the biggest issue would be, say, New Orleans and all of this region of Louisiana, which could very easily be underwater within the next 50 to 100 years in terms of all this sort of coastal wetland. Okay, so I'll leave it at that. It's a pretty straightforward lesson, not big reading, so I will make sure that everything's open for you to take advantage of that as soon as possible. I hope you're doing well. And if you have any questions, please let me know. Have a good day. Again, good health to you, and we'll talk to you soon. Bye.